Okay, let's look at the homework 5.2, 5.3, problem number 13, right? So we want to evaluate this given integral here, right? So let's work on that. All right, so first thing we do is try to find the substitution, and we let u equals to this guy, for example, right? Then derivative of 1 is 0. Derivative of e to the negative 9x would be negative 9 e to the negative 9x, which doesn't show up anywhere else, right? So here's the trick, right? So first, I'm gonna just rewrite it a little bit, right? Since I don't like having this negative power here, so I'm gonna multiply top and the bottom. So I'm gonna multiply top by e to the positive 9x, right? Then we multiply the bottom, right? So multiply the whole denominator by e to the 9x, right? To make it look a little bit better, right? So you have an integral sign, right? So you have 9 times e to the 9x. So of course you're going to have a 9 e to the 9x, right? And on the bottom, you would have, so 1 times e to the 9x would be e to the 9x, right? Then e to the 9x times e to the negative 9x. So e to the negative 9x is simply the reciprocal of e to the 9x. So they cancel out each other, so you're going to get 1, which is kind of nice. Right, then with respect to x, so you have to put dx there. Right, now this is a little easier to work with, so we're going to use a substitution. Let u be, right, I'm going to do the whole denominator, so you have e to the 9x plus 1, right? Usually having a simpler denominator is a good thing, right? So our usual drills, right? Take the derivative, so you have a du over dx. All right, so derivative of e to the 9x would be e to the 9x, right? But because of the chain rule, multiply by derivative of 9x, which is going to be 9, right? And derivative of 1 is 0, so you get that. All right, so the next step would be take the reciprocal of both sides. So I'll write it as raise it to the negative 1 power. So put it upside down. So dx over du is equal to, right? So upside down, so we'll put 1 here over. I'm going to write it as a 9 e to the 9x, right? And the last step would be just to multiply through by du, so that the dx can be written as, right, du over 9 e to the 9x. All right. All right, so let's rewrite this guy. All right, so this is going to be equal to, I'm going to go over here. Right, so we have an integral, right? Remember that we decided to call the entire denominator u, right? So you would have, let's see, I'm gonna leave a 9 e to the 9x as it is, right? Then denominator becomes u, right? And the dx is now, so dx comes from here. We can write dx as du over 9 e to the 9x, right? So let's write that. So it's going to be du over 9 e to the 9x, right? Then we can cancel out 9 e to the 9x, 9 e to the 9x, and you will get integral of 1 over u du, right? So this is going to be, so this is just a natural log, right? So we put the antiderivative is natural log of absolute value of u plus some constant c, right? Then we just need to put the original variables back in, expression back in. U is the same as e to the 9x plus 1. So we put that in. So it's a natural log of absolute value of e to the 9x plus 1, right, plus some constant c, right? So this is the answer we're looking for, right? Sorry, it takes a little longer, all right? So it's a little slow, right? All right, so let's type this guy in. All right, the answer we found was, let's see, a natural log. So we put ln, then absolute value, and I don't see it on here, so I'm going to just hold absolute value of e to the, let's see, exponential function, e to the, so hat, so shift up, right? And 9x, so 9x, right? Then plus, where's the plus sign? And oh, right there. So shift plus sign, right? 1. All right. Then you have to go to the right and then plus sign and some constant c. So it's a shift and c. All right. All right. So let's check the answer. Submit for testing. All right, it came back and looks like we did this one correctly. All right, that's it. I hope that this was clear.